Hello students, today we are going to start from exercise 10.2. Before that we shall finish two theorems. Up till now we have finished the definitions and the terms related about the circles, like we have seen the definitions of diameter, radius, segment, sector. Okay, so these all definition basic things what is there that we come to know. Now we shall go the theorems, the statements given about the circle. So first theorem we are going to prove here, that is theorem 10.1 according to your NCERT textbook. So here it is given that equal chords of a circle subtend equal angle at the center. Means as you can see in the figure, okay, in this figure you observe we have given that two chords AB and CD. Okay, because A and B lie on the circumference, and if you draw a line between sorry, between A and B, then you will get a chord that is AB. Similarly you will get a chord CD. Now you see chord AB making the angle AOB at the center and COD made by the another chord CD at the center. Okay, so these two angles are equal, we have to prove. However, we have given that the chord AB and chord CD are equal. Okay, so first of all we will write down the given things here. We have given that first we shall write down in given chord AB is equal to chord CD. Okay, that is one thing we have given, and we have given that and a circle with center O. Okay, we have one circle with center O, and obviously OA, OB and etc. are the radius. Okay, now what we need to prove here? As I told you, we need to prove that the chords are making the equal angle at the center. So one angle is angle AOB and second angle is angle COD. These two angles sorry, these two angles we need to prove equal. Okay, let us start the proof now. So first of all, in the proof, now you see in the figure we have two triangles. Okay, one triangle is triangle AOB and second triangle is triangle COD. Now in these two triangles, once you observe, the chord AB and chord CD are given equal. So one side we got equal here. Similarly, OA and OD, OB and OC, we can say they are also equal, or OA equal to OC if you are taking the triangle AOB and triangle COD. Okay, so here you see actually in both the triangles both the triangles all the sides are equal. So here we shall write down in triangle AOB, in triangle AOB and triangle COD. Okay, first of all we shall write down here AB is equal to CD, that is given in the question. AB and CD are equal. One thing. Second thing they are saying over here that OA is equal to OC and OB is equal to OD, because these all are radii of same circle. So here we shall write down radii of same circle. Okay, this complete the reason for both of them, because OA is also radius and OC will be also radius, so they both will be equal. Similarly, OB and OD will be also equal over here. Therefore, we can say that triangle AOB is congruent to triangle COD. We can say this we have proved by side congruency theorem. Okay, so therefore we say that if two triangles are congruent, the corresponding part will be definitely equal. So angle AOB will be equal to angle COD. That is with the help of CPC. And that only we were required to prove. So here at last we shall write down hence proved. This complete the proof of the first theorem. Whichever the theorems I am going to prove here, that may come in the examination also. So you have to prepare the proof of the theorem whichever we are going to prove it. Now similarly see the second theorem. In the second theorem is just a converse of first theorem. If the angle subtended by the chords of a circle at the center are equal, then the chords are equal. Means they are saying if the angle subtended by the chord means angle AOB and angle COD, if they are equal, then prove that the chords are also equal. So let us prove. Here just we are proving the opposite part. So here first we will write down in the given we have a circle with center O, comma, angle AOB is equal to angle COD. Okay, to prove. What we need to prove here? We need to prove that chord AB is equal to chord CD, right? Let us see the proof now. In the proof, first of all, we shall take two triangles as we have taken in the previous theorem. So here again I am taking the two triangles in triangle AOB and triangle COD. Okay, that two triangles only I am taking. First you see here also we can say that OA is equal to OC and OB is equal to OD. Okay, that again we have equal here. So we can write down the reason. Radii of same circle. Okay, now these two sides we got in the two triangles. But now as you know that to prove triangles congruent, we required one more corresponding part equal. So that can be side, but side is not possible because AB and CD we are going to prove equal. So that is not given equal here. But you see, we have given that angle AOB is equal to angle COD, that is given equal to us. And see here, after inserting angle AOB and angle COD equal, we can say that by side angle side congruency theorem, triangles will become congruent now because two sides and one angle, and that angle is coming between the two sides only. Okay, so we can say that here, therefore, triangle AOB is congruent to triangle COD, that is with the help of side angle side congruency theorem. Okay. Now if these two triangles are congruent, we can say that therefore chord AB and chord CD are equal with the help of CPC. Okay, as we know that if two triangles are congruent, definitely the corresponding parts will be equal, and AB and CD are one of the corresponding parts. So see how easily we have proved the first two theorems. As we go further in the chapter, then we will have some topics will be little difficult for us. Okay, now we are going to start the exercise 10.2. Exercise 10.2, you can see here first question we have given that it will look very similar of the theorem we have covered up till now, but it will be little different. See, in the first question we have given that recall that two circles are congruent if they have the same radii. Means two circles will be said to be congruent if their radii will be same. Now they are saying here prove that the equal chord of a congruent circle subtend equal angle at their center. If you see, this theorem is look same as, for this question look very same as the theorem we have covered. But in that theorem we have taken only one circle. Means in one circle only two chords we have taken, and both the chords were making the equal angle. Then we have proved the chords are equal, and if the chords are equal, we have proved they made the angle at the center same. Okay, but here we have given that the two chords on two different circles, but they are saying that both the circles are congruent circle, and for our help they have given one statement in the beginning. They are saying two circles are congruent if they have the same radii. Means two circles will be said to be congruent if the radii are same. This statement we can take in the opposite manner also. For example, if two circles have the radii are same, they will be called as congruent. Okay, so here you see we have given that circles are congruent, means their radii will be same. Okay, as per the statement it is we are going to take that things. So here first of all I will give some name. This center I will give as P, and here I will give the center as Q. Then here I will give the name as AB, and here I will give the name as CD. You can choose the name as per your convenience. So now we can say that we have two circles with center P and Q respectively, and two chords in that two circles AB and CD. And the two chords are making the angle at the center, angle APB and angle CQD. We have to prove these two angles are equal. Okay, so first of all let us write down the given things. So in the given, first we shall write down we have two circles, congruent circles, that we will add here. We have two congruent circles with center P and Q respectively, with centers P and Q respectively, and we have given that chords AB and CD are equal. That is also given in the question. Chord AB and CD are equal. Okay, so basically we have given that two things. One is chord AB and CD are equal, and we have two circles with center P and Q, and both the circles are congruent. Okay, now what we need to prove here, as I told you, the chords are making equal angle at the center, that we are going to prove it. So angle APB is equal to angle CQD. Okay, so APB is equal to angle CQD, that we are going to prove. Now first of all let us take the proof. In the proof, first I am taking in triangle APB and triangle CQD. In triangle APB and triangle CQD. Okay, now in these two triangles what we have equal, given equal, the parts are given equal. So AB and CD are given equal, that is with the help of given. Okay, and second thing I can say AP and CQ are equal and PB and DQ are equal. I am writing AP is equal to CQ. One thing. Second thing, BP is equal to DQ. How I can say? See, in the question we have given that the circles are congruent, and they only said in the beginning of the question, if two circles are congruent then they have the same radii. So here we shall mention congruent circles, congruent circles have same radii. Okay, so therefore AP and CQ will be equal and BP and DQ will be also equal. Okay, so now again you see we can apply the side congruency theorem and we can say that triangles are congruent. So first we shall write down triangle APB is congruent to triangle CQ, that is with the help of side 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 congruency rule. And if two triangles are congruent, their corresponding parts will be also equal. So angle APB is equal to angle CQD, that is with the help of again CPC. Okay, and that was only required to be proved in the question. This complete the first question of exercise 10.2. Let us see the second and the last question of exercise 10.2. So see, in the last question, what we have given? We have given that again the opposite thing of question number 1. So see, we have given that prove that if the chords of a congruent circles subtend equal angle at their center, then the chords are also equal. Okay, same thing as we have done in the question number 1. In the first question, they were saying the two circles were congruent and the chords given equal. Then they were making the equal angle at the center. It was required to prove. Here they are here they are saying that the chords we need to prove equal and they are making the equal angle at the center. The same way we can give the name over here. First I am giving the name of the chord AB and CD, and here center I am giving as P and Q. Okay, so first we shall write down the given things. In the given, first of all we shall write down we have two circles with we have two congruent circles. In the previous question, if we have not written congruent circles, please add the word congruent circles. We have two congruent circles with center P and Q. So with centers P and Q and angle APB is equal to angle CQD. They are making the equal angle at the center. Okay. Now write down to prove. We need to prove here chords are equal. Write down to prove AB is equal to CD. Right? Let us start the proof. So in the proof, first of all, we shall write down in the same way in triangle APB. Sorry, in triangle APB and triangle CQD. Okay, same triangle I am taking as I have taken in the previous question, only we shall apply a different congruency theorem. Now here as I will write down AP is equal to CQ and BP is equal to DQ. You see, this two things are equal because again we have given that the circles are congruent, and we know that if two circles are congruent then they have the same radii. So here we shall give the reason congruent circles have same radii. congruent circles have same radii. Okay. Now further we shall write down, and angle APB is equal to angle CQD. Okay, that is given in the question. So now here we can apply the side angle side congruency theorem, and we can say that triangles are congruent. So triangle APB is congruent to triangle CQD. This is with the help of side angle side congruency theorem, because two sides and one angle is equal here. Okay, and the angle is also the included angle. Okay, so if these two triangles are congruent, definitely a corresponding part we have, that is AB and CD. So AB and CD are equal with the help of CPCT. Okay, and this was only required to be proved in the question, and this complete the exercise 10.2 also. Now next time we shall start the exercise 10.3. Okay, we shall see some of the questions of 10.3. I think in 10.3 three questions are only there, so we may be able to finish the exercise 10.3 next time. Okay, thank you.